Welcome to Secret Squared. I'm Cassie Seeker. I'm Megan Seeker, and today we're going to talk about converting between radical form and exponential form, and also how to simplify radical expressions. So let's dive in. Okay, so one of the first things that we're going to be talking about today is how to convert between radical form and exponential form. So what that looks like. When we see something in radical form, it might look something like this. One of the most classic examples of a radical is a square root, and for the sake of this example, we'll just put an x in it. Now, for radical form, there are two important things that we need to know. The first thing is we need to know what the index is of our radical. Now, what the index is it's really the number that goes here with our radical, which obviously we don't see a number right now, but because this is a square root, there's actually an invisible 2 that we can write. So that 2 would be our index. If you had something like a cube root, then it would have a 3 there. That would be the index. If you have like a fifth root, it would be a 5. And the other thing that we need to know is the exponent or the power that we have. Now, in this case, our x does not have an exponent, but that really means that we have that invisible 1 there, and so that would be our power. Now, for a lot of examples, you might already have, if the example was x to the power of 3, that 3 would be your power. But if you don't see it, then in that case, it would be a 1. So once we have those two things, now we can pretty easily go ahead and convert it to exponential form. What you're going to do is whatever was inside of that radical is going to be your base. And because we're going to exponential form, we want some sort of exponent to go here. The trick is, because we're coming from radical form, our exponent here is actually going to be a fraction. So I'll just set that up now. And the trick for this fraction is you are going to use the two things that we just found, the power and the index. So I'm going to label for myself, power goes on top, index always goes on bottom. So in this case, my power was 1 and my index was 2. So this would be the exponential version of that radical form. Now you might not always have a variable underneath the radical, so you could have something, let's say you have the fourth root of 12 squared. And let me just add a little something, make that 4 a little clearer. There you go. So again, could be a number instead of a variable, but it's going to be the exact same process. So in this case, you're going to identify, hey, here's my index. In this case, because you did not have the square root, you had the fourth root, that 4 was already written for you. And then similarly, instead of having the invisible 1 as your exponent, the exponent was already written. So you have your exponent or your power of 2. So we're going to change this into exponential form. So just another way to write it, but same exact meaning. Instead of having our base be the x like it was for the top example, now our base is going to be that number 12. So we're going to have 12. And then it's still going to be whatever your power is over whatever the index is. We have our power of 2 and our index of 4. So you have 12 to the 2/4. But one more thing you can do is, and you can't always do this, but your exponent 2/4 is a fraction, you can simplify. So we're going to simplify out. Can't really see that color. So we're going to divide a 2 from the top and the bottom of the fraction. So instead of 12 to the power of 2 over 4, you really have 12 to the power of 1/2. And just be on the lookout because a lot of times teachers will ask you to simplify that exponent if you are able to. You can't always, so for example, that 1/2 you couldn't, but if you can, just go ahead and do it. Okay, so now our next example, again, we're going to be taking something from radical form and converting it into exponential form. For this one, we're going to try and make it look a little bit different, but it's actually still going to be the same steps. So in this case, we are going to be looking at a cube root. So that's that index of 3. On the inside, we're going to have a -4. And I am now going to do something with our exponent, and I'm going to put those parentheses. One thing that I want to point out is this actually would be the exact same thing as if I had written it like this. So it doesn't matter if that exponent is on the outside or if it's on the inside, they're actually identical. So it just depends. Sometimes people will write it in this way to try and throw you off. But we're still going to start the exact same way. Starting, I'm going to identify that my index is 3, and I'm going to identify my power, which is 2. And then from there, to go ahead and change it to exponential form, that -4 is what was inside of our radical. Now, because it has the negative with it, be really careful. We're actually going to put parentheses to make sure that the negative and the 4 stay together. And then I'm going to have power on top. My power was 2. My index was 3. And I can leave it right there. So I don't have to keep going any further. So technically, if you had written instead, let's say you put -4 to the 2/3, the two answers look very, very similar, but if there's not having the parentheses does make it a different answer. For the answer on the left, in this case, the entire -4 has that power exponent of the power of 2/3. If you were to write it the other way, if you wrote it this way, what you are saying is that only the -4, or that only the 4 gets that 2/3, and whatever you get from that then gets multiplied by -1. So it is different. So be careful. If there's a negative in there, then it has to stay with it. Let's say if the negative had been on the outside, then you would just tag it on to the outside after you'd have your answer. So where the negative is does matter. So we looked at a few where we're going from radical to exponential. Let's see what happens if you have exponential form and need to put it into radical form. So let's say that you have, going back to the number as a base, let's say you have 196 to the 2/3, and you need to go all the way back to radical form. The main things you need is you need to see, hey, what's the base? Because that's what's going to go inside the square roots, or inside whatever radical you may have, whether it be like a cube root or a fourth root. And then looking at the fraction, you know that you have the top number is going to be your power, and the bottom number is going to be your index. And a lot of times labeling power over index every time is a really helpful way to get it stuck in your head so that way you don't mix it up. Another trick that sometimes we like to use is we like that it's P over I. It makes us think of mathematical pi, and that helps a lot of people. Yeah, so that helps me remember the order. I think it's in pi order. So from here, we know that we're gonna have some sort of radical. So we have the radical, we know 196 can go in it. And then looking at the exponent, we know, hey, it's not just any radical. The index is going to be 3, so we're going to have a cube roots. And then also, we know that the power is going to be 2, so it's not just 196, it's going to be 196 to the second power. And if you're more comfortable with converting it from radical to exponential, you could look at your answer and double check, hey, does that actually make sense to give you the exponential form you started with? Exactly. So then that would be it. One thing just to note, and this is just something that's really easy to write it in an odd way. When you are writing your index, so right here, it's perfectly kind of in that crease. What we've seen a lot of people do is a lot of people will accidentally take that index and they'll write it like out in front. Be careful, don't do that. If you write it this way, this means that you're doing 3 times the square root of 196 instead of it being the cube root. So make sure that that 3 is clearly in kind of that crease. So just be on the lookout for it. And then our last one for switching it up, this one we're going to start with x plus 3 to the power of 1/4. So our earlier examples would just have like one number or one variable. And in this case, we have a polynomial. Exactly. So be careful. You could put a lot of different stuff on the inside, but it's still going to work the exact same. I'm going to identify my powers on top and my index is on bottom. And then to switch it, now we have that entire x plus 3. That is what has the power of 1/4. So this entire thing, that entire x plus 3, I like to put it in parentheses because it reminds me to keep it together. That whole thing has to go inside of that radical. And then I have that my index was 4. So I'm going to go ahead and put that there. And for the power, because your power is actually 1, you could leave it here. If you would like to actually write out the 1, that's totally okay. But you could actually even get rid of the parentheses as well. It's totally up to you. I'll just go ahead and put the 1 so we can see where it came from. But it just depends on you if you'd like to write it or not. So with that exponent of 1, it gives you a lot of options for how that final answer could look. Whether or not you have the exponent of 1, do have the parentheses or not. In this case, it gives you the exact same answer. Exactly. But let's say if it was a squared here, then you absolutely need those parentheses because you have to keep everything together. Now, another really important thing that you're going to see if you're dealing with radical expressions is going to be taking those expressions and simplifying them or breaking them down into their simplest form. So one example, and we'll just start with the square root because it's probably a lot more familiar to people, is I might have the square root of 28, and a lot of people, again, have probably seen it with that square root and just a number. The part that might look different with a radical expression is they might also include like a variable. So in this case, we're going to put x to the power of 10. Don't worry, it's actually way easier to deal with that variable than you might expect. So what we're going to do is we're going to start with what you're probably more comfortable with, which is simplifying that square root of 28. So if I take that 28 off to the side, And I'm going to break it up. So let's break it up into any two numbers that multiply to 28. So we can do 7 and 4. And then from there, I can break up my 4. 4 is 2 times 2. So I'm looking for pairs that I can take out of my square root. So I have my pair of 2's, so those get to leave my square root. And that is a different color. And that 7, because it doesn't have a pair, it is going to stay on the inside. I just went ahead and I left this gap because I'm probably going to have to do something with my x, so I wanted to give myself some space. So from there, now we're going to deal with that variable, and that is x to the 10. Now, x to the 10 might seem scarier than it really is. Just keep in mind that an exponent just tells you how many x's you have, or how many of whatever letter it is. So in this case, I actually have 10 x's. So I just went ahead, I took it, the x10, and I just wrote it out. It means I have 10 of them. And just like how with the number, we're looking for pairs of things, it's going to be the exact same thing here. I have a pair of x's. I'm going to keep pairing up x's. And if I look, I have 1, 2, 3, 4, 5 pairs of x's. So really what that means is we're taking out 5 x's, which would be x to the power of 5, because that exponent represents how many you are taking. In this case, I don't have any x's left over, so there aren't going to be any x's that go in here, so that would be my answer. Now, in some cases, you might actually have a variable left over, and if so, it would stay on the inside of that radical. So for our next one, we're going to make it a little bit more difficult. Instead of it just being a normal square roots, let's see what happens if we have a cube roots. So we're going to look at the cube roots of 80 times x to the 7th, y to the 8th, and z to the 9th, which looks a lot more complicated because there's a cube root instead of a square root, and you also have 3 variables. But the variables are a lot of times not the hardest part. You just have to be very careful as you're going through them. Exactly like up above, we're just going to start with the number, but we have to be careful. It's a cube root, it's not a square root. So we're still going to break down 80 or find things that multiply to 80, but when we're making groups at the end, we want groups of 2 numbers, not just groups of 3 numbers, not just 2 numbers. Because that cube root or that index that you see, that tells you how many things you want together when you're pairing or grouping them up. So 80, again, pick any 2 things that multiply to 80. Let's say you pick 8 and 10. And then you can break both 8 and 10 down a little more. 10 is 5 and 2. Or actually, it's right. 2 and 5. 8
The order doesn't matter,
yeah.
but she just had a preference for how she
8 is 4 and 2, and a 4 is 2 and 2. So you break down the numbers as much as you can until you can't break them down anymore.
Or until you get which means you get a prime number.
And then looking at all the numbers that are left, because it's a cube root, we want to find a number that shows up 3 times. In this case, we have 3 2's, so that means 1 2, because there's one group of 2's. 1 2 will leave the cube roots. And then looking at the rest of the numbers, we have 1 2 and 1 5. There's not 3 2's left or 3 5's left, so those numbers are going to stay inside the square roots. And when they're
inside the cube root.
Inside the cube root, and when they stay inside the cube roots, we're going to multiply them together. So we're going to have a 2 on the outside, and we're going to have the cube roots. Oops, sorry, make sure you can actually read that. You have the cube roots of 10.
So because again, just taking that leftover 2 and that leftover 5 and just multiplying them together.
So that takes care of that 2. And then we had the 2 and the 5, gave you the 10 when you multiply. And then going through the variables one by one, we have 7 x's. If you want to write out 7 x's, you can. Or if you think about it, we have 7 x's and we need to make a group of 3. If there's 7 x's, we can make 2 groups of 3. That gives you 6 x's. So we now have x squared
because we had 2 groups that we were able to take out.
So that x squared, that gave us 6 of the x's. There's 1 more x left over, and because that x doesn't have other x's to group with, we're going to have 1 left on the inside. So here's a visual. So if we had those 7 x's, we had we're groups of 3. 1, 2, 2 groups of 3. That was the x squared. And then we had that 1 x left over. That's the 1 x left inside the cube roots.
Exactly. So as you start, if it helps you to write it out, go ahead. But as you get more familiar with it, you'll definitely just start kind of doing it in your head.
So the x to the 7th was broken down into that x squared on the outside of the cube root and the x on the inside. Same exact process. Now we have y to the 8th. We have 8 y's. We can't make 3 groups of 3 y's because we only have 8 y's, not 9. But we can make 2 groups. So we have y squared. Oops, let me move that. You have y squared on the outside. that gave you 6 of the y's, but there's still 2 more y's that aren't put in a group. So we have a y squared on the inside of that cube roots. And then the last one, we have z to the ninth. 9z's, 3 goes into 9 nicely, so we can actually make 3 perfect groups of 3. So we're going to have, and we move this so there's some space. So we're going to have z to the third on the outside. And that came from the z to the ninth. And right here, be really careful because that 3 and this 3, they start getting really close. You just want to make it very clear that this 3 is the index. It is saying it's a cube root. This 3 is an exponent. Yes. And there's no leftover z's, so there's no z's that go on the inside, so we are good here. Just one little note on writing your answer. The order that you write the letters doesn't matter. However, you are going to find that most people tend to just put it in alphabetical order, especially because that tends to be the order that it's written in, and so most people just go one letter at a time. Okay, and then for our last one, we are going to take the fourth root. And one other thing that they might add is they might put something like 2x to the power of 3. But instead of just having this, they might take that and raise it to a power. Now, it might look a little bit more daunting, but how you want to start is let's just figure out what that is on the inside. And so on the inside, if you were to deal with this is really going to be 2 to the power of 3, which is 8, and then x cubed to the power of 3, which would be x to the 9. So once I just went ahead and I dealt with this and I rewrote it into a nicer form, then from there we can go ahead and we can simplify it pretty easily. Because it is a fourth root, we are looking for groups of 4. So our first example was a square root, so we looked for pairs. Last time it was groups of 3 because it was a cube root, and this time it's 4. So I'm going to start by breaking up my 8 because that's going to be my number. And if I break up 8, I can do 4 and 2. And I can break up that 4 some more. None of these can be broken up anymore, but the thing is I only have 3 2's and I need 4. Now that's actually okay. That just means I can't break it up. Sometimes that does happen. So my 8 is actually going to stay on the inside. And that's actually something pretty common as the index gets bigger and bigger. We have to have groups of 4 things. 8's a pretty small number, so there's no number that shows up in it 4 times. Exactly. So the bigger that index is, kind of the harder it can be to actually break things up, especially if your number is relatively small. So we dealt with our number, or in this case, we didn't have to do anything to it. And now we'll do our x to the 9. And I have some space, so I'll go ahead and write it out. 3, 4, 5. So I wrote x 9 times. I need groups of 4. So here's a group of 4. There's a group of 4. Since I have 2 groups, I'm going to bring out x squared. And I have one little x that got left over that doesn't have like a group to go in. So that'll stay on the inside. And I would leave it right there. One common thing that people might try to do is, in theory, you can take this x squared and you could write it on the end. I would really not recommend that you do that because then it isn't clear if it belongs in the square root or not. So most of the time you just want to take whatever that x square or whatever came out of your radical and just put it in the front. Thanks for watching. If you enjoyed this video, please like and subscribe. If you have any other topics you want us to cover in later videos, leave us a comment below. We'll see you next time.